Okay, so hi everyone, thanks for your attention. I'm Felix Burkhardt from Berlin in Germany. And I'd like to present my LREC poster paper about Nkululeko. Nkululeko is a framework to do machine learning experiments actually in the speech or audio domain exclusively without the need to program yourself. So at least that's the idea. Background is that I worked as a professor the last 2 years, and so I had the students as a phonetician and speech communication professor, and I had the students that I wanted to do useful things, and I'm really interested in machine learning, but they could not, didn't know how to program Python, which is pretty important to do machine learning. And so I wrote this framework in Python, actually, that should enable the students, and actually did so. I have master thesis on this base now running, for them to conduct experiments, speech-related experiments, without having to program themselves. So let me start by showing you a presentation. So at the LREC, it will be a poster, but I gave a presentation at a different opportunity. And so I think it makes sense if I show you this. It's this one. Afterwards, I think I still have time. I will give you the Hello World example of Nkululeko. So we go through a first basic example. So Nkululeko, there's a little presentation on that. It's a form-based speech machine learning tool. As I said before, I'd like to tell you what it is, how you can use it, and then perhaps some example experiments. But I guess for those you better can read the paper. We don't have the time here. And I think it's not so important. This is more about to let you decide whether Nkululeko is something that might make sense for you to use it or look at least into it. I think that's more beneficial to you now. All right, else you can come to the poster. I'm happy, of course, to help you with that. So Nkululeko, it's a software written in Python. It's hosted on GitHub. Here is this is the GitHub project. You can go there, GitHub Felix Boer Nkululeko, and then see a description on it, how to install it. And I actually also wrote a blog. There's a speech blog on my, and that's the main source of documentation actually on Nkululeko. So how here you can see how to set up the whole system. It's supposed to work for you even if you don't know how to program. I don't know how far this is true. Actually, I ran into many problems with my students when we tried that at home, to be honest. But yeah, you can always ask me. And so you see there's lots of blogs on how to do stuff with Nkululeko. But perhaps I'll show this to you later. Let's now continue with the presentation. So it's a software. It's free to use. It's MIT licensed, so you can use it even commercially if you like. It's a tool to do machine learning experiments without the need to program yourself. It's focused on a combination of acoustic features and machine learners. So here you have a little class UML diagram on software. The central class is called experiment. So one experiment is a combination of mainly machine learners called models. Here there are several models like multi-layer perceptron, support vector machine, XGBoost, stuff like this. And acoustic feature sets, that would be something like open smile features, spectra, mel specs, open crossbow, wave-to-wake embeddings, trill embeddings, stuff like this. That's just to give you a rough idea, right? So then there's classes to augment the data, and of course data set. The data themselves is pretty central. and it's meant mainly to do cross database experiments. I think this makes most sense. To evaluate the data in itself mostly does not reveal too much, apart from the idiosyncrasies of the data. All right, so it focuses on a combination of features and machine learners, and it's, I said, what did I say, frame-based or something? A form-based. So it's form-based with respect, the form is a configuration file. It uses configuration file, and there's templates, and I described them in the blog. I just showed you the blog. It's also here. And yeah, I will show you. But you fill out these configuration file templates, and then you have your experiment without for you to program yourself. So why did I do that? With the success with deep learning, machine learning dominates science, and also I think the LREC. I mean, I was a reviewer here, and there's not many papers can go through without some deep learning aspects in them. Sadly, some may say. Most of us are empiricists, and we sometimes struggle with programming. I mean, I studied computer science as well, but not all of us did, I guess. And so I know at least my students, they struggled with programming skills. So you might want to teach them, or and of course it was for my own motivation to reuse my own code. That's also a motivation. So with respect to acoustic features, audio features, I would differentiate 3 different kinds. Expert features, this is acoustic features that are modeled manually by phoneticians, like the GMAPS features, for example, brute force, every feature that is available. So like the OpenSmile, there's one feature set, the compare feature set, which has more than 6,000 features. So yeah, each frame, and that's brute force, and you definitely need feature selection then to find the best ones. And then, as I said, with deep learning, representation learning, that's a big field. So embeddings, latent space, or features learned from autoencoders are important. All of these are supported, or there is examples in Nkululeko. Of course, I use lots and lots of libraries in Nkululeko, so most of the stuff is not programmed by me, but for example, by Hugging Face, in case you know that this is used. So let me roughly go through some features. So OpenSmile features. Actually, I work for Audering. Audering is a company behind OpenSmile. OpenSmile is a library to extract acoustic features. And there are some feature sets, so different kinds of features, like pretty famous GMAPS features, Geneva, what is it here? The Geneva expert features from based on Klaus Scherer, Björn Schuller, and others, Florian Eiben. There's an extended set, 88 features, or 62. And then this is the compare features I mentioned before, more than 6,000. And derived from them, there are some more feature sets, like my colleague Uwe Reichel described in mid-level descriptors that is supposed to be, so it's based on OpenSmile features, but then gives you an idea or a concept of syllables. And so you can compute stuff like speaking rate, for example, based on this. Yeah? And another colleague of mine, Max Schmidt, is used these features to do back of words with them, back of audio words with them. So again, find which are important features. And all this is in part of Nkululeko. Then, of course, for convolutional nets, you would simply use pictures, log-mail spectrograms as features at the beginning. And then I mentioned embeddings before. 2 examples here. Trill. Trill is from Google Research Group. I think it's a clever idea to do a triplet loss-based representation learning based on contrasting speech samples that are nearby, so they come from the same sample with differentiate them from a different frame stemming from a different sample, and then so you learn this is different and the difference is in the speech, so it does some kind of representation learning. And very famous transformers in the last months, I would say, so perhaps one year or so. Great success. And so this is another form of representation learning. So you can use large quantities of unlabeled data to learn about speech, how speech works. Actually, this was tested first or developed for speech recognition, ASR, but it works quite well also for emotion recognition or other sorts of stuff. So you can download these models from either Google or Hugging Face and integrate them with Nkululeko. How to do this is part of my blog. So let me show you again. I think there's a blog on how to run, for example, should be above to back somewhere. How to set up back-to-back embeddings, for example, here, yeah. Shows you how to download, extend your environment. So you need more Python libraries for that, and then you can download a pre-trained model. So you simply download it and then you can run it. I would suggest to use Linux actually for this. So you can do it all on Windows and Mac, of course, too. But if you're not used to programming, it's probably way more easier on Linux, I guess. All right, so just general machine learning, you distinct with machine learning classification from regression. So classification, no, to distinguish between different classes would be classification, and the regressor predicts a scalar, for example, for age detection also. All of this is represented in Nkululeko. I make a quick run through here actually. Some machine learners, so support vector machines, they are based on a geometrical concept between classes, but with support vector regression, there's also regression learner based on support vector machines. And XGBoost is a very, very fast and scalable algorithm based on trees, actually classification trees, which are pretty great because they make up rules, so you can actually make sense out of them, which is one of the main criticism points on deep learning, that mostly you cannot make sense of all the weights. So XGBoost is great, and it's integrated with Nkululeko. XGR is the regression version of XGBoost. Yeah. Let's start. Then deep learning or neural networks. So the most basic is multi-layer perceptron, which is there based on Torch. Actually, the Torch library is behind Nkululeko. And then that's pretty outdated, but it's still in the other architectures. For example, this middle picture here, which I stole from some Medium article, is a convolutional network, but you see there's also some so-called fully connected layers, which is nothing else than a multi-layer perceptron. So it's still part of this. So this is a classic neural network. Up here, convolutional layer is based or has been invented mainly with pictures in the background. So this is not by chance. Here's a picture of a bird. And as you probably are aware, you can transform speech pretty easy in a picture by looking at a spectrogram, for example. So you can use these approaches directly. Recurrent neural networks are good for time series, which speech and audio is obviously a time series data, right? So it unfolds over time. And I already mentioned transformers earlier. So this is supported. Not everything yet, but it will be in the hopefully near future. And at least these transformers are integrated via Hugging Face models, and multi-layer perceptrons are already there. So now we come to the basics of Nkululeko, the configuration file. This is an example of an configuration file here. There are 4 sections. One is the experiment section, the data section, the feature section, and learner section, or the model section. And then there's a 5th one called plot. This is about what plots should be done with Nkululeko. I go through these now quickly. So in the experiment section, you can check what kind of the name, what the type of experiment. So that would be the classification or regression. And then something like how many epochs you would run the experiment and how many runs you would do. But that's perhaps too detailed now. Actually, all these features is easiest to see them in this. There's one overview, an overview on the ini file, the initialization file options, linked directly from the Nkululeko GitHub page is here, and that's where I explain for each version of, always for the latest version, the kinds of values that you can specify for here. Yeah? So all the directories, for example, in the experiment, the epochs, whether you save it or not, data and stuff like this. So you see there's quite many, lots of them. Too many, I guess, to to make sense to read this through, and that's where the block comes in. So in the block, it is better explained how you would use these value pairs here for Nkululeko. Okay, back to the slides. That's the experiment section. The data section lets you explain the databases. Oh, that's quite important, actually. There's two formats to specify audio data. Either audformat, which has been made public also by Audering, by my company. And yeah, you can look into this. It's a great format, but if it's too complicated and you want to start easy, you can also use comma separated value, CSV format. That's simply line-wise describing the data. So the first column would be obviously the path to the audio file, the WAV file, and then some features of this audio file. For example, this would be the sex of the speaker, obviously, and in this example, it's an emotion, and in this example, it's the age, right? And this is a speaker identity. Speaker identity is pretty important because you always want to run your experiments speaker independent. So training and test should have different speaker sets. That's quite clear with this kind of experiments. Yeah, that's that. Perhaps we have so there are several filters. You can filter your data for specific sex groups, for age groups, for whatever. You can there's filters for how long the samples should be and stuff like this. Sorry. Of course, you can map the labels here because I said cross data is pretty important, and obviously, often your data sets will have different labels for the classes, and then you can map them here in this initialization file. Then there's a feature section. So you describe the type of feature, open smile, spectra, multi mid-level descriptor, open crossbow, trill, or waf to back. I think that's kind of the latest. There's not more yet. Of course, no, spectra is there. Then you can scale the features. Feature scaling is pretty important. So scale for sex groups, for speakers, speaker scaling, if you know all the speakers. And standard scaling is simply Z transformation. So normalize the data. Makes sense and is very important for neural networks, actually, because they operate on small numbers. And if you use models for your features, then you would specify the path to the model here. As I said, Hugging Face models or something, an example. And then the model section, is this, what was that? There's a feature section. Okay, before we had the feature section, here's the model section. You specify, of course, the learner, so the model. I mentioned them before. And then you can, thanks to sklearn, which is also behind Nkululeko, it's a very well-known Python library. You can do cross optimization, and you can specify the tuning parameters here to find the best meta parameters for your learner. With respect to neural nets, you can specify what kind of layers, which loss function, and the learning rate, for example. And for unbalanced data, you can specify if class weight should be used. All right, so plotting section, here's an example of a actually moving plot that shows you the progress done by a learner through the epochs. Yeah, you see that the diagonal becomes more and more clear. I think it runs over 100 epochs. I do love TSNE plots. There's an example here, so you can create one pretty easy with Nkululeko to see if your features make sense at all. It shows you, so it does dimensionality reduction to only 2 dimensions, which can be plotted, and then you can color them by your class. And you see here that, for example, I think the angry class can be distinguished from the other ones. All right, some experiments I did, you find them in the paper, or also there's actually, I was really happy to see that the second paper of mine was accepted to LREC, to this conference, where we, me and lots of colleagues, compare different European acted emotional databases. And here's an example of a heat map of the outcome. And this is the paper here in LREC. So it's another poster. I'm happy to see you there. And then there's more experiments that I did. I compared and cross-database experiments, e.g., so expert features with learned features, with embeddings. They work better in this case. And there's another one example how to use this on age regression. Is an regression example here. So in order to plot the results of regression experiments, in the confusion matrix, we bin the data. So this is the under 40s, 50s years of age. All right. And then we always, you can plot with Nkululeko the distribution of the data, which is also pretty important. Okay, so I introduced Nkululeko. It's a software to do machine learning experiments, combine features and learners. It's available open source. I'm happy if you use it. Ask me questions. If we have a few seconds left, I'd like to show you how it works. So you would, on the website, there is Hello World example. It's here. It's below is a Hello World example. So these few steps should set you up for a first experiment. You need a copy of the Berlin EmoDB, which you can download from here. And then first thing you would do is create a virtual environment, VN, so it's all there. You do like this, then you have to activate it. This is different in other, so it's similar but different. It's the same in Mac OS, actually a bit different with Windows. Now this environment is activated here. And then you can already run the demo, Python. So you call it Python demos my experiment Python, like it's written here, right? So you do this and then you run into an error. The database is not found there, which is normal. So what you have to do is you have to edit. You edit the initialization file, which is this here. And I think I wrote it up here. replace the line 9. This is this one. Line 9. I prepared this, so the path to EmoDB must be fitted to your system. Yeah, so the EmoDB is a database, and on this computer it's here and not there. So I changed only this one line, and then I should be able to run the experiment. It's running. It's extracting the small features. First for the training set and then for the test set. I think it shows some output here. So as a result, how long it took, and then you can actually see it's the result is usually confusion matrix, and it's shown here. So this has been computed now. Okay, thanks. My quarter hour is 50 minutes is over, and thanks for your attention. And I'm really happy if you would like to use it and give me feedback. Bye bye.